Hello, my name is Paul Germain and welcome to Smart Boating. Today we've got a really interesting subject for you. That's winterization. Winterization is a process that all boat owners have to participate here in the northeastern part of the United States to prepare their boats for a long winter rest. The process has a number of different components within it, but one of the most important things to focus on within the winterization process are the engines. And today we're going to talk about winterizing an outboard motor. To do this, to guide you through this process, we recently interviewed Ralph Davey, who's a certified marine technician at Gloucester Marina. So I think you're going to learn a lot from this session and you're going to really enjoy it. We're at the Gloucester Marina in Gloucester, Mass. This marina has quite a heritage. It's been here for quite a long time. 37 years ago, it was purchased by the Herdman family and was built up since that time from a business that had just a couple boats in a small building to one that's a full-service marina with 150 slips and a team of certified marine technicians, very able and willing to work on your boat or motor. Today we're here to learn more about the process of winterizing outboards, and we're going to be meeting with Ralph Davey, a certified marine technician, to learn more about this process. Let's go meet Ralph. Good morning, Ralph.
Morning, Paul.
Ralph, I understand you've been working on marine engines for quite a long time. How long has that been?
It's been over 30 years.
Wow. And I noticed also that you've got a certification badge on your shirt there. What exactly does that mean, Ralph?
Well, it generally means going through schooling, taking a series of tests, not only written tests, oral tests, practical tests, and it takes a considerable amount of time and effort in order to acquire certification.
So you got a lot of knowledge. The certification means that you've got a lot of factory knowledge, factory training.
That's
right?
correct. This is marine certification, which is considerably different than automotive certification.
Okay.
Automotive individuals know quite a good deal about marine applications and engines, but there's quite a few differences.
A little bit of differences, yeah. Okay, now we're going to talk about winterizing an outboard, the process of winterizing an outboard this morning. Is there a caveat or a kind of something we should mention before we get started this morning about whether a professional should do something or you should do this at home?
Well, obviously individuals can and have tried winterizing at home, and sometimes that works well, sometimes it doesn't. The best advice would be, if you don't know exactly what you're doing, bring it to a professional and somebody that's certified and does this type of work all of the time. There's another reason for that is, in some cases, if work has not been accomplished correctly, or if there's a problem in the future, if it's a warranty situation, if it's been accomplished by a certified person or a marina application, then usually warranty is a little bit easier, but if it's accomplished by a homeowner, it might be a problem.
Okay, good points. Now, Ralph, we're going to, again, look at this winterization. Why would someone want to winterize their motor in the first place? Are there 3 or 4 key points that this process addresses?
Yes, one of the problems that you have typically is with gum deposits with gasoline. If gasoline has been left, if it's a carbureted engine, if gasoline has been left inside the engine and it evaporates, it usually leaves a gummy deposit. So that's a problem. It's one of the reasons why you typically use some type of a fuel treatment in the tank and run the engine on that type of gasoline. Another problem would be corrosion, and that's one of the reasons why the engine is run on a freshwater flushett. For 15-20 minutes, it flushes out any contaminants inside the engine, any salt if it's a saltwater application, and even in freshwater there are problems with different types of materials or sludge deposits getting inside the engine. But the other thing, of course, is you need to run the engine long enough in order to have the thermostats open, thermostat or thermostats, depending on how large an application, that allows all of the water to flow through the various passages inside the engine. Another consideration would be for corrosion But in this particular case here, it might be in the lower unit, might be water ingestion into the lower unit, and we'll get to that later on as we talk this morning. But if water gets into the oil, then that creates a problem, and water freezes, and when it freezes, it expands. And if it's in the lower unit, it could bust the aluminum housing as the water froze and expanded. Other than that, it's a matter also of lubrication, greasing all of the various fittings, and checking over the engine to see if there's anything loose or anything broken, and spraying the components where necessary with a lubricating type of oil.
Okay, that's great. Well, so those are some real benefits that come from winterizing a motor. You don't want to just throw it in the shed and come back in the spring. What process, Ralph, are we going to walk the viewers with this morning? Are we going to go through a certain process here this morning? Where are we going to start?
Well, the first item that we want to start with this morning is this being a two-cycle engine, which means there's gasoline mixed with the oil. We want to take and run this on a flushett and run it for about 15 minutes in order to go through what I just described a few minutes ago. And then we'll take a look at the power head and how we go about fogging this engine, this power head. Then I'd like to show a little bit of difference with a four-stroke or a four-cycle engine, because there are a couple of differences there. And then we'll take a look at the lower unit with draining the oil in the lower unit. And also I'd like to show where the water pump is in the lower unit, and consideration about a warranty and where a fishing line gets wrapped up. So I think what we need to do now is start the engine and run it for the next 15-20 minutes or so.
Excellent idea. Let's go ahead.
We're about ready to flush this engine with the water flushette. Key, very important part here, and that is once you hook up this flushette, which I'll show you in just a moment, and you turn the water on, you need to monitor this flushette and the water to make sure the flushette does not come off. You can always, if necessary, use a piece of rope in order to hold it in place. But if the flushette comes off, that means there's no water that's going into the water pump or the engine, and within 10, 15, 20, 30 seconds, the rubber impeller that's inside the water pump will turn to mush. It'll just melt. And in addition to that, if the engine keeps running and it overheats, you may do damage to the engine. So it's extremely important that you make sure you get adequate water to the engine with the flushette. So all you need to do is hook it up like so, and now I'll get over and turn the water on, then I'll get up inside the boat and start the engine. To comment that I added a fuel stabilizer, fuel treatment to the fuel tank earlier, and with the engine running for a period of time, the stabilizer has come through the system. I also changed the fuel water separator, so now that is full with a fuel mixture that contains gas treatment that's run through the engine. And shortly I'm going to take and use a fogging oil. You notice there's a little addition on here, and on some of the engines they have a little hole here so that when you take and put this through, it'll squirt the fogging oil into each individual sections of a carburetor. This is a two-cycle engine. It's carbureted. It has a carburetor on top which feeds the cylinder this side and this side on the top, and a bottom carburetor which feeds a cylinder on the bottom that side and that side. Obviously, if it was a larger V6 or V8 engine and it was carbureted, they'd have more carburetors on it. But you go through a sort of round rotation going around here, squirting in this fogging oil as the engine is running. In addition to that, it's always a wise idea to have some oil wipes and plenty of rags around, because if there's any spillage of oil or whatever, you want to make sure you clean it up and that you don't have any problem with the oil or grease going all over the place. So right now, I guess the best thing to do is we'll start the engine and I will show you going through the process of squirting in the fogging oil, which coats the inside of the engine with oil. After I finish, I will take and change the spark plugs, put brand new spark plugs in, so that in the spring, all you need to do is start this engine and it'll be ready to go. It'll have new spark plugs right in it.
Okay, great.
One of the things that I should mention also is that once we've started the engine and we are putting fogging oil in, we need to make sure that we disconnect the fuel hose which is feeding the engine, so that whatever fuel is left in the carburetor, the residual fuel that's in the carburetors in here, finally runs out as you're fogging with the fogging oil, and the engine it finally dies because there's no more fuel in the carburetor. That way they're left clean and there's no gum deposits left.
Okay, and is there a pattern which you put the fogging oil into the different cylinders as well, Rob?
Yeah, just sort of a round rotation motion here. Just go around in a circle.
Okay, great.
I'd like to at least show taking a couple of the spark plugs out and installing new ones. With the two-cycle outboards, the main reason for changing the plugs now is the plugs have been used for a whole season. They are worn. In addition to that, they're now fouled with oil from all the fogging oil. So by removing them and installing brand new plugs, in the spring it's real easy to start the engine because you have brand new spark plugs ready to go. So what this entails is removing the leads to the spark plug off the engine, taking the wrench and proceed to loosen the plugs like so. Then you can unscrew them, take them out. And in many cases, just by visually looking at them, not only can you see there a lot of fogging oil and you've done your job, but it gives you an idea as to how the engine may have been running during the course of the season. This one here appears to be okay, although it's filled with oil. We'll take a look and see how this one is here. And again, by visual checking, you can see, well, this one again filled with oil, but it's been functioning normally. Now, how does the average person know whether or not it's been functioning normally or not? Usually the average person really doesn't know. However, if you're a marine professional, you typically can tell just by looking at spark plugs. Now, as far as installing new spark plugs, there are, for all of the different manufacturers, more and more of them are going to utilizing a lot more in the way of metric nuts and bolts and other metric hardware, and there's a lot of metrification that's been occurring with a lot of the engines that are made not only in this country but in other countries as well. Sort of a global market now. You might have a power head that's made in this country with a lower unit that's made in some other country, or vice versa. So globalization has taken over with a lot of this construction of outboard and, for that matter, inboard marine engines. As far as spark plugs are concerned, some of them are long reach plugs, some of them are short reach, some are resistor plugs, goes on and on and on and on, and the manufacturers use different type of spark plugs for their varying engines. If you have an owner's manual, it may tell you what type of plug to use. Then again, it may not. Your marine professionals have a large variety of spark plugs as well as literature, so they can find out what type of plug specifically should be used in its application. In this particular case here, I have a couple of spark plugs I've taken out of the box. You need to check if it's a gap spark plug. You need to check with the proper gapping tool to see that in fact the gap is correct for the particular application. In this case here, that one's okay, and this one here is all right. Some are non-gap spark plugs, some you require gapping like these here. Then it's just a matter of installing the plug here and a matter of tightening right here.
For those of you just joining us, this is the Smart Boating Show. I'm Paul Germain, your host, and we're focusing on outboard winterization today. So far, what we've covered is fogging the engine to keep it well lubricated over the long winter layup, flushing the motor to remove any sort of corrosive deposits, and changing the plugs to make sure they're fresh for the next year. Moving forward, we're going to cover some additional topics which have to do with the differences between 2- and 4-cycle outboards and how you treat those, propellers, and a lot of things that are outside the boat as opposed to right there at the power head. So let's get right back.
Well, we just took a look a few minutes ago at a 2-cycle engine, which is typical where you mix oil with the gasoline. This is a 4-stroke cycle engine, and this is similar to an engine in your car. It has oil in it, like crankcase oil, and you go through the same procedure as we did before with a flushette, with water, and running it and checking to make sure the thermostat's open, making sure there's adequate water supply. And then after the engine has run for a while on a special mix, that's one of the important things, you would take and drain the oil, you change the oil. There's an oil filter here, like similar to what you have in your car, and you would change that oil filter. You make sure that you have oil wipes around because you don't want any spillage of oil. Make sure you have plenty of rags so that you can clean up any oil that might possibly drip here. This particular engine is a fuel-injected engine, whereas the other engine we just worked on was a carbureted engine. If this had carburetors on it, again, we would feed fogging oil through the carburetors. Since this is a fuel-injected engine, we run this on a auxiliary tank, a shop tank that we have, and that's a special mix. It contains not only gasoline, but also other fuel additives and preservatives. We'd run that for a period of time, which would allow the seals and whatever not to get brittle or crack, if you will, as they stay stationary during the winter months. So that's about it, and I guess the next thing we need to take a look at would be the lower units for draining the oil and taking a look at propellers and so forth.
Okay, good. Well, let's go do that.
Okay. I'm going to take and pull out the bottom plug here first, and then the top plug, and we'll take a look and see what we have for gear oil coming out of this unit. Now this oil looks pretty good. There's no metal particles. If anything were wearing inside, like gears, bearings, if they were steel, the oil would come out. It would be sort of like a pasty grayish color. If there was water or a substantial amount of water in this, the oil would come out and it would be sort of a milky color. Or if there's a lot of water, it would actually come out and it would look like whipped cream, the whitish color. And you'd lose all your lubricity of the oil on the various parts. So we're going to let this drain. I'm going to put the unit down in just a moment here. When you pull the top plug out, it allows the rest of the oil to come out. And after that, I will show you how we go about refilling the oil in just a minute.
Okay. Thank you, Al.
Well, I'm going to fill the lower unit with gear oil, and because we do many lower units here, we have a pressure tank. If you are a homeowner, you can buy quart containers with a little hand pump, which you can use for gear oil. But this works fairly well because it's under pressure. And if you notice, the engine is in a vertical position because the oil is put in at the bottom. The gear oil is put in the bottom. when it comes out the top plug, we know that we have the correct amount in there. I should also mention that in the winter time, or for that matter, whenever the engine is typically stored in outboard, it's in a vertical position. We don't antifreeze an engine like we do with an inboard engine, and so consequently any water that is in the engine runs out, so we normally don't have to worry about any freezing.
Okay.
So I guess what I will do is make sure we have oil coming out of the top, so I'll turn on the valve, and in a few minutes we'll have that filled. As you can see, we have oil coming out of the top here, so the lower unit is filled with gear oil. I'll be putting this plug in the top here, and when I go to put the bottom plug in, I would also indicate that most of these lower units typically have a magnetic plug in the bottom, and the reason for that is if there's any metal particles, steel particles, they stick or adhere to the magnet. And that way there, when you take this plug out, if you see a lot of metal particles, you know you have something going on inside the lower unit.
Okay, good.
Okay, Paul. Next thing we should consider is using some grease on the various zerk fittings on the engine. There's there are different types of special greases, but we typically use a marine grade grease which contains some Teflon. And one of the fittings to grease is here that allows the engine to turn back and forth. And then there's also some grease fittings up on the front which allows the engine to pivot up and down. In addition to that, the other consideration would be up on the top of the power head where you would take and use some lubricating oil on any of the moving parts.
Okay.
Also, on most engines, they have zinc anodes. They're called sacrificial anodes. This one is for a trim tab in this area here. This one fits down underneath here. They vary based on the different manufacturers, but they're called a sacrificial anode, and these disintegrate because of electrolysis or stray electrical currents in the water. If you're at a marina, as an example, and there's some stray currents, and what it does is it protects the bottom housing, the actual aluminum here. These are eaten away, and every year you would replace these. I'd just like to take a minute or two to comment a little bit about removing a propeller. And from a safety point of view, if you notice, I would put a block of wood here, and then after removing the cotter pin and having a wrench on it, I could turn the nut off, and meanwhile the propeller is hitting against the wood. It's not hitting my fingers or whatever. Well, just as going a little bit further, we were talking about propellers and so forth. I'd like to show you this particular propeller on this engine here. This is made out of aluminum, and during the winterization process, it's a good idea not only to check for the condition of the propeller, but also to pull the prop off and grease the shaft and check for fishing line. This particular case here, this should be sent out to see whether or not it can be reconditioned. What I mean by that is they might weld on a piece of aluminum here on the blade, the same way here where it's bent, and then shape it. If it cannot be fixed or repaired, reconditioned, whatever you want to use for terminology, then you'd wind up buying a new propeller to utilize. Now, most propellers are typically made with two materials, either with stainless steel or with aluminum. Aluminum propeller is more forgiving if you wind up hitting a sandbar or hitting a ledge or rock or whatever it might be, because the aluminum will have a tendency to give and bend. And therefore the aluminum takes all of the impact load and deforms. With a stainless propeller, they're more expensive and they are a tougher material because they're made out of steel. And if you hit a sandbar or a rock or a ledge, in a lot of cases, the propeller may bend a little bit, but the impact load is transmitted to the propeller shaft, and inside the lower unit is where all of the gears are, and in some cases it may take and affect the gears inside so that the gears either may snap or the shaft may break, or there might be some kind of internal damage occurring because of the stainless steel prop. That's not to say that they don't last a long time, because they do. But again, like I mentioned, aluminum props are a little cheaper, and they take the load and they bend and break. Down here, you'll notice I have the propeller off of this lower unit. This is a spacer, and fishing twine gets wrapped around on the inside of this propeller shaft, and this will have a tendency in many cases to take and ruin the oil seal in there, and the oil starts leaking out, water gets inside, and then you start getting into what I was describing earlier, this milky white type of oil. And this portion right in here, this is the water pump. Inside here is the rubber impeller, and like I was indicating earlier, the flushett allows the water to go in through here, up through the water pump, and then up through a copper tube into the power head. And if you do not have water going through that flushett, that rubber impeller that's in there will burn out in just a matter of 15, 20, 30 seconds. Also, from the warranty point of view, usually you need to drop this lower unit once a year to check on the spline shaft here, reinstall it with grease, and in this day and age they're very critical about warranties and making sure that you do adequate servicing to your engine, the lower unit and the power head. Then, after putting some grease on here, you would reinstall it with proper grease and proper zincs, etc. If there's any concern that you have, or you don't know exactly what you're doing, and also from a warranty point of view, probably the smartest thing you can do is bring it to a local marina and have somebody that's certified work on it. Have a professional do it if you're not sure what you're doing. Okay, Paul, one last final comment, I guess, would be in regards to batteries. I know that usually comes up. If you have a completely fully charged battery, you can leave it in your boat for the winter months with the cables disconnected. One of the considerations, obviously, is what part of the country you live in and how cold the temperatures get. If a battery is left in a boat not fully charged, then there is a greater chance for the battery to freeze. That is the electrolyte inside the battery. In general, probably most people typically undo the battery connections, take the battery either to their home and put it in the cellar or the garage, and they may have a trickle charger to keep it charged. It is important to note, though, that these batteries are filled with sulfuric acid, which can burn your hands or burn your eyes. You should wear protective glasses if you're working with any of these batteries, and that's, from a safety point of view, very, very important. Other than that, I think that probably wraps it up pretty well, except to say that if there's any questions or doubts that you have, there's a lot of marinas in the area, and there's a lot of certified marine technicians, and any problems you have, it might be worthwhile to visit those
Well, that concludes our session on winterizing an outboard. As you can tell, it's a critical process to ensuring your boating safety and pleasure. Outboard motors, like all marine engines, need to be protected properly against gum buildup in the fuel systems, corrosion, cracking due to water freezing in places it shouldn't be, and lack of lubrication. Special thanks today to Ralph Davey and the members of the Gloucester Marina crew. I'm Paul Germain for Smart Boating. I hope you've enjoyed this session and that you join me again for another session soon. Thank you.